Every single day, millions of tires roll over a surface so common we barely notice it. A smooth, dark ribbon that stretches across cities and countrysides, silently supporting our entire way of life. But peel back that blacktop, and you'll find a world of ancient recipes, fiery furnaces, and precise engineering that most of us never even think about. So, what is it that actually holds our world together? It's not just a simple layer of tar, it's a sophisticated composite, a carefully engineered sandwich of stone, sand, and a sticky, primordial goo. The story of how this surface comes to be is a journey that begins not at the construction site, but millions of years ago, deep within the earth. But before we get to the massive machines and the blazing heat, we have to ask, is this a modern marvel, or something we've been walking on for millennia? Believe it or not, asphalt's roots are ancient. What we know as a roadway was first used by our ancestors as a kind of superglue. The earliest engineers, the Mesopotamians, discovered natural seepages of bitumen, a thick, black substance that bubbled up from the ground. They didn't pave roads with it. They used it to waterproof their temples and seal their boats, making them river-worthy. Fast forward to the bustling streets of 19th century Europe. As cities grew and the horse-drawn carriage became the king of the road, the search was on for a surface that was durable, dust-free, and smooth. In the 1820s, Paris saw a radical experiment, a modern asphalt sidewalk, a sign of things to come. It wasn't until the automobile burst onto the scene that the true potential of asphalt was unlocked. Suddenly, the demand for strong, quiet, and flexible roads exploded, launching asphalt from ancient sealant to the undisputed champion of modern infrastructure. So what gives it this superpower of flexibility and strength? The answer lies in its recipe. If you think of a road like a cake, the asphalt is just the icing. The real magic is in the ingredients. The binder, the glue that holds everything together, is bitumen. This isn't just some random goo. It's the heavy leftover residue from refining crude oil. It's incredibly sticky and waterproof. But bitumen on its own is useless. It needs a skeleton. That skeleton is the aggregate, a precise mix of crushed rock, jagged gravel, and sharp sand. In fact, over 90% of the road is just this rocky skeleton. The bitumen, making up less than 10%, acts like the mortar, decoating every single stone and binding them into a unified, powerful mass. This blend gives roads the perfect paradox. They're hard enough to support a 40-ton truck, yet flexible enough to expand and contract with the scorching summer sun and the freezing winter cold. But that perfect blend is useless without a solid foundation beneath it. Before a single ounce of that black mix touches the ground, a massive amount of unseen work takes place. Think of it like building a skyscraper. You don't start with the windows, you start with the bedrock. Construction crews first clear the land, stripping away anything that could shift or rot. Then they bring in the heavy artillery, giant rollers that pound the native soil into a rock-hard, stable platform. This is the subgrade, but it's not enough. On top of that, and they lay down a thick layer of crushed stone, the subbase. This layer is a drainage system, a crucial barrier that prevents groundwater from seeping up and destroying the road from below. Above that goes the base course, an even thicker layer of larger interlocking rocks designed to spread the immense weight of traffic across the entire surface. If any of these foundational layers are compromised, it doesn't matter how good the asphalt on top is, the road will fail. With the foundation set, the star of the show can finally be created. While the ground is being prepared, a fiery industrial ballet is happening miles away at the asphalt plant. The process begins with the aggregates, the stones and sand, being fed into a massive, rotating drum and heated to extreme temperatures, often over 300 degrees Fahrenheit. This step is critical. Any moisture in the rocks will turn to steam later and ruin the bond. Simultaneously, the bitumen is heated until it becomes a free-flowing liquid. The two ingredients are then combined in a meticulously controlled mixing tower. This is hot mix asphalt, and its temperature is everything. It needs to leave the plant at around 300 to 340 degrees Fahrenheit. hot enough to flow and coat the stones, but not so hot that it burns off the essential oils. Once mixed, it's dumped into insulated trucks, which race against the clock. The clock is ticking because this molten material has a limited window of time before it cools down and becomes unusable. It's a race against the inevitable cool down, and it ends at the edge of the new road. The trucks arrive, and the transformation begins. They dump their glowing, steaming cargo into the hopper of a massive machine called a paver. This machine is a marvel of engineering. As it inches forward, it takes the loose, hot mixture and spreads it evenly across the prepared base, creating a smooth, continuous mat. Behind the paver, a crew walks alongside, carefully ensuring the edges are clean and the joints between lanes are seamless. It's a coordinated dance of man and machine. But here's the thing. That smooth mat they just laid down? It's not a road yet. It's a fluffy, air-filled layer of hot rocks and glue. It has the consistency of a dense, warm cake. It has no strength. The secret to turning it into a solid, permanent surface is one of the oldest and most important steps in the process, compression. And for that, you need the rollers. As soon as the paver passes, the rollers move in. This is the compaction phase, and it's arguably the most critical moment for the road's longevity. Massive steel drum rollers, weighing several tons, begin to pass back and forth over the hot asphalt. Their job is to squeeze the air out and force the hot bitumen to lock the aggregates into a tight, interlocking matrix. If this isn't done while the mix is still hot, the air pockets will remain, water will get in, and the road will crumble. Different rollers perform different tasks. The steel drums provide the initial, powerful compaction, while pneumatic rollers, the ones with rubber tires, knead the surface, sealing it and giving it a finished texture. A road is forged in fire and finished under pressure. Once the rollers have finished their work, the road transforms from a loose mixture into a solid, impermeable surface. It then needs to sit, cooling and hardening, often for several hours, before it can bear the weight of the world. Finally, after the asphalt has cooled and the surface is rock solid, the finishing touches are applied. This is where the road becomes a complete system. Crews come in to paint the lane markings, the crisp white and yellow lines that guide us. They install reflective cat's eyes and rumble strips for safety. They put up signs, ensuring the flow of traffic is organized and efficient. Only after this final layer of information is applied does the road open to traffic. So the next time you're cruising down a highway, think about the journey beneath your wheels. It's not just dirt and tar. It's a layered system engineered from the ground up. A foundation of compacted earth and crushed stone, a skeleton of rock, a binder of ancient refined oil, all bound together by fire and pressure. From waterproofing Mesopotamian boats to supporting the global network of modern life, this humble material has proven itself indispensable. It's a testament to human ingenuity, taking raw materials from the earth and transforming them into the very pathways that connect us all. We drive on the history of the earth, bound by the ingenuity of man. Thanks for watching Winds of Thought. If you've ever wondered how skyscrapers stand up to the wind or how the internet actually works, let us know in the comments below. Don't forget to like and subscribe. We'll see you on the next journey.